Hello everyone. We are going to continue our class of foundation engineering. Normally we should go with the next chapter 6, combined footing, but we will combine these two chapters, chapter 6 and chapter 7. Okay, so combined footing and mat foundation, but we will talk more about mat foundation. Okay, so this is the content of this chapter: introduction, combined footing, second position, and we will talk about the common type of mat foundation and bearing capacity of mat foundation, and settlement, also differential settlement of mat foundation, and also settlement observed on field. Okay, field settlement observation for mat foundation, and compensate foundation, and at the end we will talk about how to design, okay, structural design of mat foundation. Yeah, this is roughly what we are going to discuss in this chapter. Today, this video is just the introduction. We will do only the introduction, okay? Only the first point. And I leave you with that. You will digest, and we will come back to continue the other point. So let's go then for the introduction. It will be very short, you will see. So what we did in the previous chapter, chapter 4, 5, everything was like isolated footing. Okay, what we discussed in chapter 4 and 5. No, this kind of footing we have like a square or rectangular footing, and they are like very economical for supporting columns and walls, like retaining walls. In some cases, we have no choice but coming up with other type of footing. Okay, and the footing may support, in that case, a line of two columns or more. Okay, if we have this kind of case, we have we cannot call them any footing, isolated footing anymore. Okay, the name will be combined footing. Okay, or you can see the illustration here. For example, you have here one footing but supporting two columns. Okay, you can see many examples here. This is a photo, so not a drawing, so it will be easy to understand. So if you see this, this is what we call combined footing. And sometimes we have even several columns, lines of columns that are supported by concrete slab. Okay, like instead of having slab roof, we have concrete slab on the ground that will receive a lot of columns. Okay, in that case we will talk about mat or rough foundation. Okay, this is example. For example, you have the whole building is resting on this slab. You cannot see like a single isolated footing or combined footing like this. Everything is like one giant footing, or let's say slab. So in that case, we call it mat or rough foundation. And as you can guess, we cannot design this kind of foundation as the type of foundation we discussed in chapter 4 and chapter 5, isolated footing. Okay, so in this chapter, we are going to see how to design bearing capacity, okay, of the ground that is receiving this kind of foundation. Yeah, so let's discuss more in detail about this combined footing. Okay, this combined footing, we have several categories. We can have rectangular combined footing. For example, this, you can see it rectangular shape, huh? It's rectangular, and you have two columns coming. Okay, you may have also trapezoidal combined footing like this. You can see here it's shorter than this side. The shape is like trapezoidal shape. okay? And we also may have strapped footing. So in that case, you have like two isolated footing, but connected with this, we call it strap beam. Okay, you can see here a photo. You have a footing here, each of them receiving a column, but we connect them with this kind of beam, strap beam. So strap footing. Okay, so all these are called combined footing. Yeah. Next, let's see what we can say about the smart foundation. Okay, so this smart foundation, we generally use them where the soil has low bearing capacity. Okay, so we have some very special circumstances where we choose to go for the smart foundation. Okay, the first one is when you have like more than 50% of your foundation. If you want to do uh, uh, the foundation isolated footing, it has to be part or strip foundation for all, like all the building, 50%. Okay, so means 50%, more than 50% of the footprint will otherwise be uh, part or strip footing. Okay, and sometimes it's not easy to do that. So instead of doing that, we just go for like a slab on the ground, mud foundation. And the second case that lead to mud foundation is when the structure requires that the settlement, the differential settlement. I think in the previous chapter we really uh, discussed about what is differential settlement. Okay, please go back and see. When the differential settlement need to be very small, need to be limited. Okay, so some very important structure, the differential settlement uh, is not allowed to be too large. So in that case, you go for mud foundation sometimes. Okay, and the last case when we go for mud foundation is when there are non-uniform soil condition, because sometimes soil change even within 1 meter distance. So, but some job sites are very complicated. The soil changes too much. This place is hard soil, and just one path away, you have one step away, you have a very soft ground. For this kind of condition, you go for mud foundation, it's easier. Okay, or sometimes you have weak, good soil, but there are some pocket of weak soil in the ground, so you go for this mud foundation. Okay, so I think that will be all for this introduction. Just digest this, and from next video we will go to see step by step how to design this kind of foundation. Okay, thank you very much for your time, and see you next time. Okay, thank you.